All right, guys, we're going to go ahead and run through CFA 6.3 and 6.4. Make sure you've got your study guide going here, and you can be re-listening to the explanations here and writing down the answers. All right, so we're going to use bar models here to solve these expressions here, these equations. Okay, so the first one, we've got 5x plus 12 equals 7x plus 4. And remember, when we make bar models, we put 1 on the top, one side of the equation. So 5x plus 12. And I'll divide it like that. Those added together would give me the whole bar. And on the bottom, I've got 7x's, which would be a little bigger than 5x's, plus 4. And our job is to figure out what x is. So remember, we've got to try and cancel out things that equal each other here. So I'm going to re-look at this here, and I know if I have 5x's here, that would be 5x's here. And I know I had 7x, so I'd have 2 more x's. And I know if this is 4 here, then I know this has to be 4 here, and those are equal. And I know this whole thing had to be 12, so this will become 8. And this is still 5x plus 12, and this is still 7x plus 4. Now I know these 7's equal each other, these 5x equal each other. So really what I'm left with is 2 x's have to equal 8. So sometimes we can rewrite this, and I'll just do this part of it. I have those 2 x's there, and they have to equal, we'll kind of just divide it like it was up in this other one, 8. So I know then that each x has to be 4, because 4 and 4 equals 8. So in this case, x has to equal 4. And let's go ahead and plug that in, substitute, double check that it works, always verify it. 5 times 4 is 20. 20 plus 12 is 32. And we said x is 4, so I'll plug it in here too. 7 times x, 7 times 4 is 28, plus 4 is 32. So both sides equal each other, and I know x has to equal 4. So that's an example of solving an equation using a bar model. So again, make sure you get these copied down here. I know this is hard to see right in here, but this should say 5x right here. Okay, and this part, I'll move it over there in case you couldn't see it there. Okay, but 5x and 5x equal each other. Okay, again, don't have to use all these boxes. Sometimes we just put some extras in there, depending on how you divide that up. Okay, so make sure you get this written down. Pause the video if you need to. All right, then a word problem here dealing with this. Okay, so this says Julie is 5 times older than Kim. Kim is 12 years younger than Julie. So got to do some good reading there. We need to define a variable for Kim's age. So let's let K stand for Kim's age. And we're going to write an equation you can use to model and solve this. And then we'll use that bar model to solve it. So Julie is 5 times older than K. So if I'm going to write that equation, I could write 5 times K. 5 times older means you're multiplying by 5. And Kim is also 12 years younger than Julie. So that means Julie is Kim plus 12. Because Kim is 12 years younger than Julie, that means Julie is older. Both of these guys, both sides equal Julie. Okay? Because she's 5 times older than Kim. And at the same time, she's 12 years younger. Kim is 12 years younger than Julie, which means Julie is 12 years older than Kim. So both of these equal Julie, so they're equal. Okay, so if I'm going to use that bar model to solve this, I could have 5k is the same as 1k plus 12. And again, I'll go ahead and change this around and try to figure out what 1k is. So I could divide these 5k's separately, because I know I had a k down here, and those equal each other. And this has to be 12. And then I can see 12 has to be divided up among 4k's. So 12 divided by 4 is 3. So I know every one of these k's could be 3. 3, 6, 9, 12. So how old is Julie is what they want to know. We know right now Kim equals 3. Okay, we know K stands for Kim. So I've got to plug that in here to see how old Julie is. I could take 5 times 3. I can plug the 3 in here as well. I could do it on either side. And 3 plus 12 is 15. So Julie is 15 years old, and we know Kim is 3, so we could easily tell both by using that bar model. The tough part sometimes is getting this into an equation, okay, getting into algebra language there and written out, in an algebra way. Okay, so make sure you get this copied down as well. I've been studying solving using bar models. All right, then on the back we've got these pan balance problems. And we'll take a look here. We know we can use these to solve as well, so getting some thinking down on how we'd keep this balanced. Our job is to find out one square weighs the same or is the same as how many paper clips. So we know we can cross some things off here. I know these 2 paper clips, if I take 2 off each side, it would still be balanced and weigh each other. So what I'm left with is 2 triangles, or excuse me, 2 squares equals 6 of those paper clips. So I've got 6 left over here. So 2 of those squares. So I know one square has to be 3. This square would weigh the same as these 3. This square would weigh the same as these 3. So I know one square has to equal 3 paper clips. So basically you're cutting this in half, right? Okay, and each square is worth 3 paper clips. Okay, and we'll look at one more here. Again, get these copied down. And then down here, this one's a little harder to see. But we've got the balance below has triangles and weights of different values on each side. I notice I've got some weight dumbbell here. This is a 2, kind of hard to read. This is a 4, and this one's worth 8 in this one here. So kind of tough to see. Write it above too, just in case you can't see that. Okay, so let's start taking some things off here. I know if I take off one triangle here, I must take off one here. It would still be balanced. So I've still got 12 pounds over here, 4 plus 8, and 2 pounds here. So we're trying to figure out what one triangle equals. Okay, so I'm going to go ahead and take off these 2 pounds here. If I take off 2 pounds on this side, I must take off 2 pounds on this side. So instead of weighing 4 pounds, this weight we could say weighs 2 pounds now is one way to look at it. Okay, because I took 2 pounds off of each side. So what I'm left is 2 triangles. Because I've got 2 triangles left over here, and that's it. And I know I've got 8 pounds here, and this became 2, so that weighs 10. So again, I can just cut that in half, and I know one triangle has to equal 5 pounds. Okay, because this one would weigh 5, this would weigh 5, it'd be a total of 10, because I have a total of 10 left over here. So I know one triangle would equal 5 pounds. So again, just another way to think about solving is keeping both sides balanced of an equation, whether we're dealing with shapes or whether we start dealing with numbers or variables coming up here when we're solving equations. So lots of different ways to think on how to solve bar models and pan balances we focused on in this CFA. So make sure you get this stuff written down.